Yeah, this is my first time at NACIS, and I just got to say I'm really inspired by all your guys' work, so I'm really happy to be presenting here. Today I'm going to be talking about how we're using drones and maps to push forward our work with plant conservation in Hawaii. If you're not familiar with the Hawaiian Islands, Kauai is the furthest to the northwest, the oldest of the Hawaiian Islands and the most biodiverse. I work for the National Tropical Botanical Garden, and we have 3 gardens on Kauai, one on the east side of Maui, and one in Miami. I'd like to start with a story about these 2 guys. This is Ken Wood and Steve Perlman, a couple of my colleagues at National Tropical Botanical Garden. They've been working in Hawaii for almost 50 years, and they're both transplants from the mainland US. Steve came out in the early 70s and had a background in rock climbing, so he started applying rappelling techniques to survey the cliffs of Kauai. And over the course of their careers, they've discovered hundreds of new species with this method. And in 1992, National Geographic wrote an article about them and termed this phrase rock star botanists. But with all that work, there's still areas that they're not able to get into. And so I kind of see this as like a continuation of their work. And this is just an example of sort of what the rugged terrain of Kauai looks like. And a light bulb just kind of went off for me, and I thought, wow, we should really try drones and see if we can survey these areas. So it's a huge area, and I had to kind of start whittling it down and figuring out where I wanted to start. So this is a rare plant Refugia model from some scientists at University of Hawaii, Manoa. Basically, it's a relative probability of areas having rare plants. What's unique about this one is a lot of species distribution models, they just put one species or one genus in the model, but this is all our plant collections from 50 years, pushed through the model, and came up with some interesting results. It's still too much, so I restricted it to cliff habitat. And this chart basically just shows the relative probability on the x-axis and the total acreage on the y. Basically, what we already knew, rare plants exist on cliffs and have a high probability of being there. So when I started out, I was really excited about doing these photogrammetry models, and it became very time-consuming to produce these and take all the photos. And it wasn't the most efficient way for me to find rare plants. So I quickly switched gears and went into like a more manual flight method and also manual image classification. So I'm taking the raw photos straight out of the camera. Here's one in one of our preserves. And then I go in Adobe Lightroom and circle each of the plants that I see in those photos. I spent a lot of time squinting at the computer screen. It's time consuming, but it's the most accurate way that I've found to do it. So we've been using it to inventory plants. This is the Blue Hole area of Kauai, one of the wettest spots on Earth, with about 3,000-foot cliffs. And there's a few, 4 or 5 species that only exist in this cliff system. And until now, we've never really gotten a chance to look at them. This plant right here in the middle is Lysimachia Iniki. It's named after Hurricane Iniki because that hurricane broke off some pieces from the cliffs, and our botanists found it at the base of the cliffs and described it. And until now, we had never really been able to see it in situ. And so we were able to inventory and figure out the extent of these plants with the drone. Another plant I'm going to talk about is Hibiscus woodii. This is a relative of a hibiscus that was discovered in 1994 by Ken Wood. And there was only 4 plants found at that time. By 2007, all those plants had died, and we thought the species was extinct. So we wrote a grant recently to go looking for it, and we used drones, and we were able to re-find it, so we're using it for plant discovery as well. This is the location of it. I don't know how we'll ever get there, but it's cool to know that they're there. So I'm using Adobe Lightroom, and I love that I can catalog and organize all my information in this format. I can filter it by field day, and it'll just show me the species that I map for that day. It has a map feature, but I actually prefer to take it out and put it into ArcGIS. And that's sort of one of the problems that I'm having now, is getting all that data that I create in Lightroom and moving it into Arc or Arc Online. So what I've been doing is putting the species name and the number of individuals into the file name, and then stripping it out with string operations in ArcMap, and then pushing it out to Arc Online. So this is an example of a 3D web map that I use. It's great to be able to see the plants in this way, especially on really steep cliffs. You can symbolize by species. You can symbolize by number of individuals, and then I also have them hyperlinked to the individual plants, as you can see there. So we're also using them to guide our field operations. This is a plant called Wilkessia hobdii. Originally, we thought there was about 700 of them, and through comprehensive surveys, we've found about 7,000. So, 10-fold increase in the number of plants. What's really cool is I can go in and take photos of the individual plant that I want to get to and push those back out into offline field maps, and then our field collectors can rappel down and go right to those individual plants that have seeds, so making our field operations much more efficient. I also use these maps for reporting. So rather than writing up thick reports and submitting them to U.S. Fish and Wildlife or the state of Hawaii, I just can send them this web link, and they can filter and get the locations really easily. So that's saving me a lot of time in reporting. And then the last part is sky truthing. So we just kind of coined this term. We wanted to check how efficient this model was at predicting rare plants. And we haven't gotten into any deep analysis of this yet, but we're finding that the points line up really well with this predictive model. So we're really excited to keep using it and explore around in the cliffs. I'm going to finish with this photo. It's really awesome how drones and maps are helping us find these little pockets of intact native cliff habitat, and just an exciting time. So my contact information is there. I don't know if I have any time for questions.